Hello everybody, Mr. Hasty here again. Today we're going to cover section 10.4, which is on applications of sound. So the first one we're going to talk about acoustics. Acoustics is the study of sound. So there are a couple different jobs associated with acoustics. One is the design and creation of venues. If you understand how sound moves, you might build something like a concert hall, as shown in this picture. This is actually for classical music and opera, and it's specifically designed in a way to make the sound clearer, louder, amplify it with muffling noise. These little sections here are specifically to recurve the sound towards the audience. So there's an entire study in physics of understanding how sound moves, how it operates, and building structures to make that, to use that to our advantage. That's why certain places are good for holding concerts and certain places are not. A loud, cavernous cafeteria is bad for transferring clear sound, whereas a music hall is specifically designed to make things sound good. Another thing that this is used for is soundproofing and adjusting sound within places like your house. One of the reasons you have curtains besides to keep light out is curtains also are made of porous materials, which means that they have holes and teeny tiny little holes, and they're made out of soft material. And the reason why these are actually good is they absorb waves really, really well. Because they're so light and they move, as the wave strikes it, the wave actually gets dampened. And that means that it gets lessened so that the volume is less. That's why it's harder to hear somebody if you were to like wrap a towel around your head or if you're wearing a hoodie or a lot of layers. It can be hard to hear through all that material. Whereas other materials, typically harder materials with densely packed particles like metal, stone. Well, stone's actually porous. Metal and certain types of wood reverberate, they resonate really well, and they help to amplify and create sound. Whereas soft materials like cloth help to dampen sound. And so acoustics, people who study acoustics study these kinds of behaviors, and they use them to create the effect they want, either a loud, clear sounding environment or to dampen sound. All right, next we're going to talk about echolocation. Echolocation is actually the basis for a lot of types of applications of sound. So echolocation is the process of emitting sound and interpreting the reflection of those waves. Sorry then. Now, this shows a picture of a bat, and bats famously use sonar. They emit a very high frequency pitch screech, and when that frequency hits the bug, it reverberates that sound, and that's how bats actually quote unquote see. A lot of animals use forms of echolocation. Bats, some types of whales, some types of birds, and some types of rodents actually use echolocation to seek out things underneath surfaces. So the basic process is the creature emits a sound wave. When that sound wave bounces off of something, it can then interpret. Now remember, that's called a reflection, but in sound we call it an echo, hence the term echolocation. It can interpret what the sound just bounced off of and use that information to effectively sense its environment similar to how we see. A variation on this is sonar, which is specifically a technology of using sound waves underwater to detect objects. Now, the most common thing people think of when they think of sonar are submarines and naval vessels. They use sonar to detect things above them and below them in order to ascertain the location of allies and enemies in a combat situation. Another application that's used a lot is for actually trying to find things that have sunk into the ocean. So treasure hunters use this. If a ship crashed, let's call that the ship, I can't draw, and let's say that ship had something of value in it, or you just want to discover what happened to it, the boat on the surface might use echolocation, and what they'll be able to do is they'll send the signal down, and they'll be able to tell the difference between the signal that rebounds from the floor and the signal that rebounds from the ship. And part of that has to do with what we talked about earlier about acoustics. Sand is going to have a very specific, it's going to absorb a certain amount of the sonic energy, so the reverb is going to be very specific. But a ship is going to have a different material, and that means it's going to reflect a different amount of that sound, a different quality of that sound, and you could be able to tell based on the sound you get back what exactly it is you're looking at, or at least that it's different than everything else in the surrounding area. Another application is an ultrasound. Now, ultrasound, we talk about ultrasound technology, but what ultrasound is it's a sound with frequency above 20,000 hertz. And because it's above 20,000 hertz, humans cannot hear it. Now, because the frequency is so high, it actually penetrates particularly human bodies. And so ultrasound is used as a technique to, most famously for a technique to see fetuses and embryos in the womb. The other applications would be seeing medical anomalies like kidney stones, because kidney stones are hard mineral deposits, which will have a very different structure and reverberation than the surrounding tissue. And so we use ultrasound machines to generate these frequencies of sound directed into the human body and then interpret the rebounding signals to form an image. So, quick review. We have a few different applications of sound here besides the one we talked about last section, which is music, which is a very common application of sound. We have acoustics, which is the study of sound used to make environments louder, quieter, more clear in terms of sound, any of those qualities. Echolocation, which is used by a variety of animals in order to detect predators, to detect prey, to find food, various things like that. Sonar, which is technology we use in the water both for military applications and for exploring. And ultrasound, which is used in the medical field as a imaging technique. All right, that's all for today. Tomorrow we'll be reviewing for the quiz. See you then.